and welcome to another edition of the InfoQ Podcast. I'm one of the co-hosts, Wes Reisz. Together with Daniel Bryant, I host the InfoQ Podcast. Today on the show, we are talking about keeping data in sync between services and in large-scale distributed systems, specifically change data capture with Debezium. Our guest is Gunnar Morling. Gunnar is a software engineer at RedHat working on Debezium, a project he leads. He is the spec lead for Bean Validation 2.0 with Jakarta EE. He's a Java champion. This podcast uses a talk that Gunnar did at QCon SF just a few weeks ago. If you like what you hear and you want to dive a little bit deeper, the video will be available on that presentation on InfoQ.com in just a few weeks. Gunnar, welcome to the show.
Hey there. Hi, Wes. Thank you so much for having me. I'm super happy to be here.
Yeah, this was a tough one to get scheduled. I'm glad we finally got it all done.
Absolutely, yeah.
The first question I have is probably the first question that you get every single time you say the name of this project, Debezium. What is Debezium? Where does the name come from?
Right. So definitely it comes up every time I talk about Debezium at conferences and so on. And just before the talk, I actually went back to our FAQ to see what our founder wrote about it, because I wasn't quite sure actually myself. So the idea is like an element, right? Like you have plutonium, neptunium, uranium, all those chemical elements. And so there's Debezium, so there's DB database in it. So that's kind of the idea. It connects to databases, and then it's kind of this cool element in your overall system architecture.
Very nice. Okay. So we're talking about change data capture and streaming data from like data sources. Change data capture is a technique where changes to a database, say before an insert, can push like an event to a log.
Right.
And I've used it in the past for things like auditing and things like that. So why Debezium? What does Debezium give you that just say a stored procedure or talking to a database doesn't?
Okay, so yeah, the primary point of it is to be able to react to data changes with very low latency. So typically within tens or hundreds of milliseconds, we would be able to capture an event. We would stream it to the outside world, typically going through Apache Kafka or other comparable messaging infrastructure. And then you would be able to connect any sorts of consumers, and they could react to those change events. So it allows you to react to your data changes with very low latency.
So what does it give you that's like different than maybe like a native way of doing change data capture with like a data store? Is there like some secret sauce? What does it do?
Okay, so, well, first of all, it's based on getting changes out of the transaction log. So maybe you're thinking about ways for implementing something like this, for instance, using triggers. So you could have triggers which are sitting within your transaction path, and then they, for instance, do some, copy of your data into another table. So this means this is on the execution path, right? So it will slow down your incoming requests. Whereas the log-based change data capture, this all happens asynchronously. So the performance of write requests to the database is not impacted. So this all happens asynchronously. And then essentially what sets Debezium apart from maybe comparable solutions is it's all open source, and it works with a range of databases. So you could connect it to MySQL, to Postgres, to SQL Server, and a few others. And then for a consumer, it would not matter too much what the particular database was where this is coming from. So we strive for having one rather generic abstract event representation.
I see. So the basic is log versus query. It's more performant because it's looking at this distributed log, basically.
Exactly, right. So there's different ways people could look at this. There's triggers. So there's the performance overhead, but also there's typically quite an overhead in terms of managing just the trigger infrastructure. So you must keep them in sync with your model and so on. And typically DBAs are just not so excited to have tons of triggers there. Then query-based CDC, that's certainly a way to do it. So essentially it means you would go to your tables and you would poll for changes regularly. So there's a few disadvantages coming with that. The basic problem is there's some sort of conflict between how often you do this and then also what kind of load does it create. So you would like to poll very often, so chances are higher you get the latest changes. But then, well, you wouldn't want to query your large tables every second, right? Your DBA might complain, please don't run this query all the time. And still, no matter how often, how frequently you would poll, you would never be sure that you don't miss a change. It could always happen that between two polling attempts, you would miss an update, or maybe something gets inserted or deleted right in the next second. So you might never see this record. And this isn't the problem with the log-based approach, because all the changes, they are like added to the database's transaction log. So we will be able to see all the changes in their correct order. We will be able to see deletes. So that's also something you couldn't get with polling. And also there's no impact on the design of your table. So for something polling based, you would need to have some columns which help you to identify the records you need to get there, right? Whereas from the transaction log, we can get any table changes without any requirements towards the table structure.
Yeah, makes sense. So I used an audit use case. Can you give us just a simple use case that Debezium really excels at?
Right. So I work on this, I think, for 2.5 years. And it's funny because I still keep seeing more and more interesting use cases. So for instance, the auditing one you mentioned, this just recently came into my mind and we were doing a demo on the blog about it. But what most people, I think, use it right now for is definitely replication. So propagating changes between different databases, maybe across vendor boundaries. So going from, let's say, SQL Server to Postgres, maybe they have like a testing or a staging database, which they would like, they would like to have a free open source database, which might be different from what they run in production. So you can do that. You can replicate data into your data warehouse. That's a common use case. But also you could use it to stream changes into a search index. So very oftentimes people would like to have some sort of full text search capability, and databases are not so great to do that. So there's dedicated things like Elasticsearch or Solr, and now you could use CDC to replicate the changes from your operational database into those search indexes.
You mentioned open source. A couple questions here. So where does the project come from? And when you say open source, is it truly open source, fully open source? Is there an enterprise version? So where does it come from? And tell me about the open source strategy.
Yeah, so that's definitely something which is very close to my heart. So it's all completely open source. It's Apache licensed. So RedHat, the company I work for, so they are a big sponsor of it, but then there's also a big community around it. So I just checked the numbers before we got on the recording. And right now we have 140 people which have contributed to the project. So some of them, they just fix a bug and then they go away. But we also have people who stick around, who work on this stuff for a longer period of time. And also something which I would like to grow in the project is to have more community engagement and taking care of entire connectors. So for instance, we just recently added a connector for Cassandra. So that's in incubating status right now. And actually, this one is led by folks from another company, which is called WePay. And they worked on this connector in-house at first. And at some point, so they still are big users of the Debezium MySQL connector. And then they began to work on this Cassandra connector in-house. And then they decided, okay, let's open source this under the Debezium umbrella. And so they are still in charge of this. But really, it's like a joint effort of a larger community.
Debezium pops up all the time in just things that I'm seeing and talking to.
That's great.
But the project hasn't been around that long. How long has it been around? How many deployments? What kind of companies are using Debezium?
Okay. So, yeah, I think it's around for, let's say, 3 and something years. So Randall Hauk, who founded it, I think he started in 2016. Or late 2015, maybe. I joined in early 2017, so I worked on it for 2.5 years. So it's not around for that long. But as you say, it has been, or we are seeing huge deployments in production. So this is very interesting for us to see, because sometimes somebody comes to the mailing list and they say, so I use the Debezium Postgres connector and I use it to stream, changes out of a couple of hundred databases. And now I run into this particular performance problem. And that's great feedback for us because, well, I don't test with a couple of hundred databases, right? I just don't have this capability. So it's very good to see this kind of feedback. And they said, okay, for instance, we are using, 80 gigs of heap space. Is there anything we could do about it? And then, well, we can work with them and optimize those numbers for them. So we are seeing huge deployments. Some of the users I know are there. For instance, there's a Convoy. So I think they are like a startup on the logistics business, like some Uber for freight. There's BlaBlaCar, there's Trivago from Germany. There's many others. So we are right now compiling a list of public user references on the website. So if anybody is listening and they would like to be there, just let us know.
So still on this open source part, what's the release frequency? What's that look like with the project?
We are doing it the good open source way. It happens when it happens. So what we try to do is try to stick to a 3 weeks cadence. So this means we would like to have a release every 3 weeks. This would not always be a final release. So for instance, right now we are at the 1.0 beta life cycle. So we would do 1.0 beta 2, let's say last week, and then 3 weeks after that, beta 3, and at some point the final. So that's what we try to do. We always stick to one version which we maintain. So let's say once we are at the 1.0 branch where we are right now, we wouldn't go back and do earlier releases just because we are a small core team, so it's not maintainable. Yeah, so that's it.
Again, there's one repo, so everything is upstream.
Right. So everything is upstream. So we have the Debezium organization on GitHub. All the stuff is there. It's definitely not like an open core model where, certain features are held back and they are just for paying customers. That's something RedHat never does. It's all fully open source. There's different repos. Currently, we have repos for the incubating connectors. They are located in a different repo, but otherwise it's all there and, it's equally accessible for even the website. So if you found a typo on the website, you also could go there and just fix it.
You mentioned a few connectors. I want to just kind of give some breadth on what it is. You've mentioned Cassandra. You mentioned Elasticsearch. I've seen MySQL. So what are some of the connectors that are out there?
First of all, about Elasticsearch. So that's a sync connector, which exists in the community. So this can be used with Debezium, but it's not part of Debezium itself. In terms of the CDC connectors we have MySQL, Postgres, MongoDB, SQL Server. Those are, let's say, the most mature and stable ones, and they are huge, definitely big time in production. And then we have two more, which are currently incubating. So it means, their record message might change and active work is happening on them. And that would be Cassandra, which is being led by the WPay guys. And then there's an Oracle connector. So that's also something we are working on. And then there's another one, which is for IBM DB2. So that's actually really a cool thing, which came out of the acquisition of RedHat by IBM. So all the time people were asking us, so hey, when do you do a DB2 connector? And we always said, well, we would happy to have it. It's just we are a small core team, so we don't have the bandwidth to do it. So if somebody else would like to do it, we would definitely love to have it under the Debezium umbrella. And then shortly after the acquisition was finalized, some folks from IBM came and said, oh, so by the way, we would like to contribute that to Debezium. And so this is happening right now too.
Let's go through a simple kind of bootstrapping use case. Say, I don't know, we've got a service, it's got MySQL, and we want a cache or a Solar Search or something along those lines. Tell me, what do we need to be able to set this up?
So you would use Apache Kafka. So that's what most people do. So you would have your Kafka cluster, typically multiple nodes to have scalability and high availability and so on. And then by default, you would have there one topic for each table you're capturing. So let's say you have a customers table and a purchase orders table. You would have two topics with the corresponding change events. So they would be located in Kafka. And then there's this other effort from the Kafka umbrella, which is called Kafka Connect. And Kafka Connect is a very interesting thing because it's a runtime and also a framework for building and operating connectors. So you have their source connectors, which get data into Kafka, and then you have sync connectors, which take data out of Kafka topics and write them to some external system. And then essentially Debezium is a set of Kafka Connect source connectors. So you would deploy them into Kafka Connect, and this is its own process. So this again could be scaled out and so on. You would deploy the Debezium connectors to Kafka Connect. The connectors would then establish a connection to the databases. So it would be a remote connection to the database. And then when they are notified about any change event, the connector would go and write the changes into the Kafka topics.
So, okay, Kafka Connect has a JDBC connector that lets it talk directly to, say, like MySQL or something along those lines. And the difference between using Debezium versus that is back to that log versus query. Is that correct?
Exactly right. So there's a JDBC source connector, which is polling based. So it comes with the implications I was mentioning. But there's also a point to make about it. So you can use that one with each JDBC accessible database. Whereas for the log-based approach, well, we need to have a dedicated connector for each and every database. So there's no one single way we could implement Debezium for all the databases. We need to have a dedicated connector. If your particular database isn't supported, then you would go for the query-based one. But otherwise, I always would recommend the log-based approach.
You mentioned Kafka. What about other things like Kinesis or Event Hub on Azure? Could you support other event logs or distributed event logs?
So yeah, this question also comes up pretty often. So currently it's not supported out of the box, but you can go there quite easily yourself. And this is by means of what we call the embedded mode of operating Debezium. So this means you also can use Debezium as a library, which then is embedded into your Java application. So you would build a small Java runtime, like a small Java process. You would run the Debezium connectors as a library there, and essentially you would register a callback method. And this callback method will be invoked whenever there's a new change event coming in. And then within this callback method, well, you can do whatever you want, right? So you could send this message to Kinesis, to Google PubSub, and so on. I definitely know people are using this with all those different messaging infrastructures which are out there. And what we want to do going forward is we would like to take this to the next level. So we want to have some sort of standalone mode for Debezium. So this means it would again be its own process, which would be based on this embedded mode. But then you don't have to deal with, gluing the things together. So this would be a ready-made runtime, which you could deploy. Maybe we would have a Kubernetes operator for that. And you would just configure it. So we would have different, let's call it output plugins. So we would have a plugin for Kinesis, and you would just configure this, and then you would run this particular Debezium process.
Yeah, very nice. With the libraries, is there a certain version of Java that you support? Are you following long-term LTS? Where are you?
Yeah, so we try to be conservative. So we require only Java 8. So everybody should be on 8 by now, right? So that's the minimum version. It definitely works with new versions. We are testing it with 11, and it should also work with the latest ones.
So you mentioned, as you were talking about this kind of simple setup for Debezium, that for each table responds to an individual stream. What if you want to join streams and you want to have a materialized view or something that's on the other side? Does Debezium support that?
Right. So you definitely have multiple options to get there. So you would have this one-to-one relationship between table and topic. So that's the default. But you also could actually reroute messages to a different topic. So in Kafka Connect, there's this notion of single message transformations, and they allow you to modify messages either as they are sent into Kafka or as they are taken out of Kafka. And one use case for applying them on the source side is to route Kafka records to different topics. So if you have change events from multiple tables and you would somehow correlate them, aggregate them, whatever, one option could be to configure such an SMT on the source side to send all those messages into one and the same topic. And from there, you essentially could process them in sequential order. So you got to be careful about keying, but you could do that. Another option is you could use a stream processing engine like Kafka Streams. So this would allow you to do this kind of processing after the fact, essentially. So it means you would have a streaming app which would take those different topics and, for instance, would join them based on a time window fashion. So that's definitely an option. We are having some plans to further improve the usability around this. So, for instance, we would like to expose an additional topic which contains information about the transactional boundaries in your source application. And this essentially would allow a Kafka Streams application to essentially await all the messages which are originating from one transaction, then produce one aggregated structure, for instance, which is consistent in regards to that transaction.
In microservice architecture, we create these bounded contexts around, an order that's happening, and everything comes in through the service that modifies to this data store. Debezium kind of sits on the back of that and is taking events out. Does that mess with the idea of a bounded context? Are there any things you need to think about? How is that addressed with Debezium?
I think it's definitely something you need to keep in mind if you would like to adhere to the domain-driven design practices. So again, there's multiple things you can do. So I think the underlying question is, well, I'm exposing my internal table structure to the outside world. And is this a problem? Or if it's a problem, how can I deal with that, right? And I think for a certain category of use cases, it's actually fine to do that. So thinking about going to the search index, I would argue, well, it's your very data structure you would like to have in the index. That's the data you would like to make searchable. So it might be fine to just expose it there. And then if you changed your internal model, let's say you add a column to your table, chances are you would also like to have this in the search index. So that's just fine to expose the structure. So there's a category of use cases where it's like this, I would say. But then there's another category of use cases where it might be more of a problem. And this is if you really talk about exchanging data between multiple, let's say, microservices. And there it might be a larger concern. You don't want to expose, let's say, your customer table structure to the other servers. So again, just using those SMTs might already be a useful tool because, well, you could use such a single message transformation to prepare the structure of your messages. So for instance, let's say you did some change to your internal model, you renamed something. Well, you could use such a message transformation to either undo this change and not expose it, or maybe expose this renamed column using both the old and the new names. Consumers would have some sort of grace period in which they have to adjust to this change. So SMTs might be an option. I think the ultimate answer is a particular pattern, which is called the outbox pattern. And then the idea there is you don't capture the structure of your internal tables, But what you do instead is, as part of your writing application, you update your business tables. So let's say you update your purchase order table. And then at the same time, you also do some inserts into some outbox table. And this outbox table, this would be like a messaging queue, which is meant to propagate messages from your system to downstream systems. So within the outbox table, you would insert message records. And in the simplest case, you would just have a single column there. It would be the payload. So this could be anything you would like it to be. It could be a JSON structure, really anything. So this would be your defined messaging contract. And then you would use Debezium just to capture the changes, the inserts from this outbox table. And consumers would react to those events from the outbox table. So there's support for that in Debezium. So for instance, we have again a routing component which allows you to route those events from the outbox table into different topics. So you don't end up with one huge outbox table topic, but instead you could have different topics for each event type. So that's something you can use with Debezium out of the box. And the most important thing about all this is this decouples your internal structure from the external message structure. So now you are free to rename your columns, you'll remodel your things. You just have to be careful that you evolve this message contract you use in the outbox table, that you evolve this in a compatible fashion.
Yeah, that makes sense. When you're not using that pattern, when you're back more in the kind of exposing the internal table structure, are there any challenges around like the change data capture events that are being published? What I'm talking about is like late arrivals and time and things like that you have to address with other data sources. Like you're in MySQL, you're sending something to Oracle or to Redshift or something along those lines. Are there any challenges with the ordering of events that you have to be aware of?
I wouldn't say so much challenges, but just some things you need to be aware of, and the guarantees you get, you need to understand them. And essentially, if you're using Apache Kafka, what is guaranteed for you is the ordering of messages within topic partitions. So this means topics, let's say our customer change event topic, it could be partitions, so just to make it scalable across multiple nodes. And then in Kafka records, they have a key and a value. And in our case, the value of the change events, that's the actual change event structure with the old record state, the new record state, and so on. And the record key, that's the primary key of the table. So now all the events, our customer 1, 2, 3, they would have the same message key, essentially 1, 2, 3. And then Kafka would make sure that all those change events for this particular customer, that they go in one and the same partition of this customer's topic. And now for a consumer, if it reads the change events from this partition, it's guaranteed that it sees the same order of events as they were produced with. So this means we essentially have the guaranteed order of all the records which pertain to the same record. What we typically don't have is a global ordering across all our customers or all our purchase orders. But usually that's not something you need, right? You're more interested with ordering within such an aggregate like customer or order, but you don't need to have the global order across all your purchase orders.
Let's talk about maybe some challenges that might come up. What about things like debugging? What does that experience look like if I'm trying to debug a system that we'll say it's using the outbox pattern? How do you go through and kind of debug this when you're using Debezium?
Yeah, so let's say the good thing there is one of the engineers working on Debezium, so he has a very strong background from QE, so he was a quality engineer for many years. So this matter is always close to his heart, and he's always very keen on making things, testable, traceable, and so on. So this is very good to have his input there. So essentially, we expose options, for logging, obviously, so you can fine-tune the logging level, so you see at a very fine-grained level what the connectors are doing. You have metrics, which you could expose via JMX, and then from there you could go to Prometheus and Grafana. So you could even do some sorts of dashboards which show you, what's the throughput of the connectors, what's the lag. That's a very important number, right? So you would like to be sure that you can keep up with the frequency of changes that's coming in. So all these things allow you to get some insight into the running connectors.
You mentioned lag and latency. You're talking about all these different systems that can process things at different rates. Everything's published into Kafka. So I get that. But how do you deal with like lag, and how do you deal with like different consumptions and producer and consumer rates?
So essentially, there's some notion of back pressure built in. So this means, if we cannot keep up with change frequency, we would do it as fast as we can. But the important part there is the changes are stored in the database, in the source database, as long as we need them to be. So at some point, we will have processed all the changes, and typically we will notify the source database, okay, we have processed the log up to this particular point, so now you can discard this log. So this is, for instance, something which happens in Postgres. So the guarantee always is that nothing gets lost. Also, if the connectors are down for some time, then the transaction logs in the source database, well, they will be retained. Of course, you need to be aware of the disk space which is used by this, right? So if your connector is down for 2 weeks and we cannot get the change events, well, the transaction logs from those 2 weeks would pile up on the source database. So that's something to keep an eye on. But, well, if you have some monitoring around this in place, then it's fine. In Kafka, well, you would scale out your topics typically to manage the load. And what I know from the community, they are usually very happy with the end-to-end latency. So, for instance, I know there's people, they have 2-second end-to-end delay going from their production database to their data warehouse. So within 2 seconds after something has changed in their upstream application, they see it in the data warehouse. So that's typically the numbers we look at.
So CQRS allows us to divide up reads from writes. It seems like Debezium could be a nice solution to help you here. Is that a common use case that people are using to help kind of scale out their reads?
So I think it's not the most common use case, but it's definitely something people use it for. So you could argue even just having data in Elasticsearch, it's already some sort of CQRS, right? Because now you have a particular model which allows you to query for things which you couldn't query in your primary database. But definitely, I think people also are at least exploring this to denormalize their data, for instance, into stores such as MongoDB, where you can have like nicely nested structure. So that's also a question which comes up very often. So here I have those two tables, order lines and order headers. So my purchase orders, they're persisted in those two tables. And so I would get two change event streams out of Debezium, whereas Elasticsearch or maybe MongoDB or anything where I can have this kind of nested structure, I would like to have a single document which contains one purchase order and all the relations which belong to this aggregate. So maybe the order lines, maybe shipment addresses. So all this should go into a single document, which I then could query very nicely on all those properties. So that's something I'm very eager to explore. I think Kafka Streams can play an important role there. It would allow you to implement this kind of denormalization. And then, well, if we had this metadata topic, which I was mentioning before, where we would expose transactional boundaries, then we would allow such a Kafka Streams process to build those aggregates in a transactionally consistent way. So that's one of the things we would like to explore going forward.
That's a great segue into roadmap. What's on the roadmap for Debezium coming forward over the next 12 months or so?
So again, it's the open source way. So it's so we have a roadmap which has things we have in mind, but then this all is driven by the community. And very often it happens, somebody comes up with an important, or with a great idea, and well, we would reply, hey, how about you implement it yourself? And chances are people do it. Well, and then this naturally gives it a big bump on the roadmap, and it would just happen quickly. But on the things I would like to see, definitely moving forward with those incubating connectors. So for DB2 for sure, hopefully for Oracle, we can move forward for Cassandra, so to make them stable and production ready. Then this standalone mode I was mentioning, so that we would have a Debezium server kind of thing, which would be able to send messages to Kinesis, Google PubSub, and so on. We would like to have cloud events support. So this is something which comes up in the community more and more. So we have the cloud events spec by the CNCF, which describes a standardized message envelope. So we could have a mode which allows us to export change events in a cloud events structure. And then, for instance, you could use this very easily with Knative eventing, for instance, to build your serverless eventing applications. Those are the things which are on my mind. Building those aggregate structures in a transactional safe way, this is something we would like to support. Maybe some more primitives which you can use with Kafka Streams services based on change data topics.
Very nice. Well, Gunnar, thanks for joining us on the InfoQ Podcast.
Absolutely. Thank you so much for having me. It was really a great experience. Thank you.